Okay, so let's go over this warm-up. Now, when we first did solving equations the first unit of this year, I made you show all your steps. That gets annoying after a while, and so I'm not going to show every step every time today. All right. So we're going to add these two. We get 1. We move it to the other side. We get 1. We always divide by the coefficient, and sometimes it makes a fraction.
I got that.
Good. Excellent. That's what I expect. You are meeting my expectations. Okay. Now, the second one is a system. How would you like to solve this system? Okay, what do you think, Matt?
Multiplication.
Multiplication, which is elimination. So we're going to multiply the first one through by what? 2. And the second equation through by 3. And the process is not hard at all. So that gives us 4x minus 6y is equal to 20. And 15x plus 6y is equal to 12. So now, because this is equivalent to this, it's like adding a value of 12 to both sides when I add this system. This gives me 19x, y's cancel, equals 32. We don't like Miss Willoughby. She just gave us an ugly crap answer.
I got that.
Good. I'm glad you got that. Now, if you had written these from like some type of real world application problem, more than likely you would not leave your answer 32 over 19. But if it is a straight math problem, we would definitely leave our answer 32 over 19 because that's the most exact answer we can get. But you just lost half credit. Why?
Because you didn't turn it into an improv.
You didn't find the y.
Yeah.
You only gave me one variable. How do we go back and get the other? Plug in. Yes. So we get 2 times 32 19ths. And even without a calculator, we're okay.
We are.
Oh, yeah. Because 2 times 32 is 64. And since I'm about to move this 64, I can go ahead and write this with a denominator of 19. Because if I multiply 19 times 10, isn't that just 190? So then I move the 64 19ths over. Well, when I do that, it's like subtracting 64, right? So we get that. Matt, you need patience. This is a good problem. This is good stuff. You do not want to miss this, do you? No, I didn't think you did. Alright, so you can think of this as dividing by 3 or multiplying by 1/3. Either way you think of it, the negative 3 ends up down here in the denominator, doesn't it? Alright, well 3 does go into 126. How many times?
That's first order.
Negative 42. Good. 19ths. So there's my solution. 32 19ths, comma, negative 42 19ths. Beautiful.
That was beautiful.
That is beautiful. Okay, and we can do that algebra, right? All right. The next one is just the rule. So the rule that would transform this function by reflecting it over the x-axis, shifting it up 5 and to the right 2 would be y equals negative out in front. That reflects it over the x. A minus 2 up there shifts it right 2 and then up 5.
Yep.
Are we good? Okay, second warm-up of the day. There it is. Okay, now, you agreed on your summer work to learn your squares, 1 to 20, and your cubes, 1 to 10, and some other powers. So, you should be able to knock this out in 32 seconds. Go.
Wait, we agreed to do the,
I learned
And your summer work.
the powers? I thought we only did
Some simple powers.
squares and cubes.
Okay, we'll do all that you can do.
Are you judging us?
Every day. It's my job. I get paid to do that.
Who does a fit?
I didn't see the.
Without, you didn't see it without a calculator?
I didn't see that. I was like, can we use a calculator?
16. 32.
I don't remember. I'm so proud of myself because I thought we were going to have a test.
We are. We use it often and all year.
No, I thought we were going to have a test on all of those, so I studied. Hey, I'm actually aware that they're all summer, actually.
I don't remember. I know. I know.
Okay. No, that is not math.
You're on the same line. I'm done. Oh. I do not know. Do y'all know Sabrina? Wait. 4? Alright. Yeah. Okay, square is 4. 8, 16, 32. No, it's 1 now.
No, it's not. 60. No, you could multiply by 2. Because
Okay.
you multiply by the next number. I mean, there's the power 4.
I'm done.
Whoa, what is the last one?
Hopefully your brains were turned on and you caught the things I was hoping you'd see.
Yeah.
Okay, 10 to the 3rd was an easy one and you went, Miss Willoughby, why bother? That's 1,000. 15 squared, that was on my list. That is 225. 12 squared, we learned in 3rd grade. That's 144. Okay, this one you may have counted on your fingers, but 2 to the 5th is
32.
32. Now this one and this one. This is, if I read it out loud, I would have to say the opposite of 2 squared, which is -4, versus this one is -2 quantity squared, which is
I don't get it.
+4.
I don't get it.
Oh, yeah, because it's like a -1 multiplied by.
Exactly. This is like a -1 multiplied times 2 squared. That's what this means. -1 times 2 squared. The opposite of 2 squared. That's what it means. All right, 7 to the 3rd was on your summer packet.
343.
343.
I got that.
Okay, 4 to the 4th was not on your summer packet, but
256.
it is 256.
Bam.
And let me show you a different way to think of this. This is like 16 squared. 2 to the 4th is just like 16 squared. Now why is that? Because isn't 16 2 to the 4th? And some of you already know this rule. But when we raise a power to a power, we multiply the exponents. So do you see why 16 squared is the same as 4 to the
2. I see
4th?
that. I see that.
Okay. Now, so this would be the same as 25 squared,
If you wanted to.
right? Okay, and that would be 625. This is 10 squared 100. This is the opposite of 1 to the 4th, which is -1. This is negative 1 to the 4th, which is
1.
positive 1.
Uno.
Okay, now the bottom part leads us in exactly into what we're doing today. What power do I raise 2 to get 16? 4. 7 to get 49.
2.
7 to get 343.
3.
Okay? 4. 3.
5.
5.
I got them all right.
Awesome. Awesome. Okay, so let's revisit the things I expected you to know from the summer packet. So your squares 1 to 20 and 25. Your cubes 1 to 10. Now, powers of 2, we ought to be able to do these really quickly up to the 10th power. Because you can count on your fingers to the first 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. You can count on your fingers really quickly and do this. All right, so those are your powers of 2. Now, here are your squares, 13 to 20, because 1 to 12 we learned before we left elementary school. All right, so here's 13 to 20 and 25. And then your cubes, 1 to 10. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. Yes, Matt?
Whenever you recite numbers, your eyes get really, really big.
It's exciting. Yes, I get very excited about numbers. I was just telling the teacher standing out there last night, I watched this webinar on this new calculator app, and that was very exciting. It's a TI Inspire app, and the calculator itself is close to $200 if you bought the calculator, but the app is only $29.99. And with the app, it'll do everything the calculator will do, plus you can take your iPad, and I could take a picture of something. This calculus teacher took a picture of the college pennants that were on the wall and used it as the background to his graph, and then modeled the functions on top of it, and you can see the functions laying right on top of the picture. And then with an app versus a calculator, it works just like an iPad. We can tap on it and it's around. So we can take that line and shift it. Just like we've been shifting things by hand, graphing, you can just do it with your finger on the iPad. And if you want to do a vertical stretch, pinch out. If you want to do a compression, pinch in.
That's legendary.
Isn't that cool?
Well, everything on the App Store.
It was very cool.
Can I buy
So you could buy it. I haven't bought it yet. It's $29.99, which is much cheaper than the actual calculator. But let me buy it first and let me play with it enough to know if it's worth y'all buying. Those of you that might have an iPad at home,
Wait, does it work?
and I'll let you know. I don't think it works on the phone.
Wow.
Never mind. Although I do have an iPad.
Yeah.
It's my mom's.
Okay, so today we're going to be solving exponential equations. All right, so we're solving for x, which happens to be an exponent today. So we're going to do some more solving. Now, you see this first question I have written twice. Because, first of all, you guys should be able to look at this problem in this class. All of you should be able to look at this and go, Miss Willoughby, the answer is 4. There's nothing to do. Okay, but I want us to think in terms of when we solve exponential equations, we're going to write them with a common base. We're going to write it with the same base. And not to solve really simple problems like this first one, but to solve the more complicated ones that we'll be doing later on. But let's see how it looks with a very simple one. This is 2 to the x. But 16, can we think of it as 2 to the 4th?
If we want to.
Yes, we can. We can rewrite 16 with a common base. We have 2 here. We can write this as 2. And once you get the bases equivalent, the only way that this can be equal is if this exponent has the same value as that exponent. If we have the same base, the only way it can be equal is if this exponent has the same value as that exponent. Does that make sense? Okay, so x has to equal 4. Okay, so we're going to apply it to problems like this. Because we know that 16 is 2 to the 4th, and now this one gives us 2 to the 3x, we know, because they have the same base, the only way they can be equal is if this exponent equals this exponent. So 3x has to equal 4. So in this case, x is 4/3. And that's our answer.
But how?
Does that make sense?
Because if they've got it equal, like the exponents have to equal if the base is the same. That way they'll be equal.
Okay, so let's do a lot of the kinds where I give you the same base to start with. So we have 3 to the 2x and 3 to the 6. The only way these two quantities can be equal, because we already have the same base, is if this exponent is the same as that one, if they have the same value. So we'd set 2x equal to 6. So what does x have to equal? 3. Okay, now a different base, a base of 5, but both of them have the same base. So the only way these two could be equal is if this exponent has the same value as this one, if those exponents are equal. Okay, so we would subtract 2x from both sides, and x equals -2. Okay. I would like you to try 1 and 2.
Yeah.
Please try the you tries 1 and 2.
Alright, I'm gonna do it on the back one.
That's fine.
This is hard.
Huh?
This is hard.
You think so?
No, it's not.
You just put these.
All you gotta do is put the exponents equal to
It's
each
just
other.
solving equation.
Because the base is the same, so it's 4x.
I don't know how to
plus
solve
x.
exponents.
No, you just do it like this, Mac. Because the bases are the same, you do 4x is equal to x minus 6, and then you solve it like a normal equation.
What?
Like that, and then you just solve that.
Well, you could have told me that.
That's what I just said.
Could've told me that too.
Thank you, Kate, for telling me that.
Right? Am I
Okay,
right?
that's what I told you here and here. And so these are the same.
It's so hard though.
No, it's not.
Boy, y'all
Okay,
are-
so did you get -2 for number 1?
Yeah.
Good. Alright, so let's take a look at number 2. Because we already have equivalent bases, we can just set the exponents equal to one another. X minus 7 is equal to 6x. So we subtract x for both sides, and we get -7 equals 5x. We divide by 5, and -7/5 is the answer for x.
I was scared I got that wrong.
Okay,
Weird.
now,
Fractions make
I
me
do
scared.
that on purpose because a lot of us in here are bright enough to where we could look at this and figure out what it would have to be if it's an integer answer without doing any work. So I'll give you those fun
But those
answers.
make me think I'm wrong.
Don't! I'm telling you right now, I give them to you.
Don't you hate that when you think you're right at like a whole test, you don't get like a
Yeah, that's the
It's
one.
like a
that's the math.
77,
If
yeah.
the test is easy.
Okay.
like a 55 or something. In biology.
Biology.
Okay, Miss Willoughby,
All right.
I did what we just did.
Next problem. All right, so if we look at the next one, we're taking it a step further. In the next one, we have 5 to the x equal to 25 to the x minus 1. Well, we don't have the same base. But we can rewrite it so that we do have the same base. And what you always want to try first is, can I take that larger base and rewrite it as a power of the smaller one? Yeah. 25 is what?
It's the
5
squared.
squared. Okay, so I'm thinking here, 25 is 5 squared. And this one I don't have to change because it already had a base of 5. Well, now I have the same base. Okay, now let's go back to what we talked about in the warm-up. When you have a power raised to a power, a power to a power, we multiply the exponents. So let's make sure we do the 2 times the x minus 1. Power to a power, you multiply the exponents. So this exponent here is equal to the product of those. Does that make sense?
It does.
Okay, so we get x equals 2x minus 2. Subtract 2x, negative x equals negative 2. Divide by negative, x equals 2. Now, let's check to see if we did it right. How could we check to see if we did it right? Plug it in. So where the x was, we think of a 2. Okay, so we get 5 squared. What is 5 squared? 25. And over here we get 25 to the 2 minus 1, which is 25 to the first power, which is 25. Did it work?
It did.
Yes, it did. It did. Check. It worked.
Alright, can
Okay.
I try this one?
Not yet. You can try this one.
Okay, that makes sense.
All right. So let's look at both of these.
100.
Okay, this one's a little different, but it's the same idea. Can I write 125 as a power of 25?
You could do 25.
No,
you
to the
not a power of 25.
No.
25 to the first is 25. 25
You-
squared is 625. So
5
it's-
cubed.
but I can write them both with a base of 5. 125 is 5 cubed. And 25 is 5 squared. So every time we're trying to write them with equal bases, with equivalent bases. So here we get 3x, and here we get 2 times x minus 1. So we get 3x equals 2x minus 2. So x is negative 2.
I see that.
Okay, here's your first you try. Okay, before you start, can you write 16 as a power of 8?
No.
No.
No, because our first 8
Oh, yeah.
squared is 64. Okay, so what are we going to do?
Power of
Power
2.
4
Power of 2. Power of 2. Good. So rewrite both of those bases as powers of 2.
Will you rewrite both of them as powers?
Yes, you would.
Got it.
Oh yes, I got 2.
I see what I did though.
You're wrong.
Yeah, see, that was wrong. Okay.
That stinks.
But you get 24.
I thought I was wrong, but I really wasn't.
Miss Willoughby, I don't like when you do that. You
Miss
do
Willoughby?
it once.
Could you write it as negative 5?
Yes, you can.
Some weird.
I'm like,
no.
that's
Well,
not gonna be
4.6.
Whatever. Then
Yeah,
you get
Yes,
6.
yes, you could. Because the decimal is terminating, you sure could. If it were non-terminating,
You can
I
write
would just-
1 and 3/5. I mean, 4 and 3/5.
okay. One more you try before we move on from here.
I think I'm ready to go.
Okay, so don't go past my squiggly line. But you try that one more, and let's see what you can do.
Ooh, that was good.
Yeah, JK, IKR.
Okay. Oh, it is?
Like, he's wrong, I might try.
Oh, why not? Yeah, I get that.
You do?
I'm not sure if I got this.
He's slow walking up that
Probably not.
ladder.
No, she was standing at the door, so I waited for her. She waited for it, and then I went like this, and then she laughed. And when she laughed, she went like this, and I was like, because her teeth were like.
Let me look at my S's.
There's no way I got this.
What did you get?
3 to the power what to get 81?
4.
Oh, no, I
Yeah, I got 20.
I told you, I'm not right. I don't think other people trust me.
Yes!
Side, and then I swear it is 81, so you add 3.
Yes, you guys get more than. What round did you get?
When you guys were what did I do?
Congrats.
Oh, wait, no. Yes! Willoughby, I got it.
I'm not looking yet. I'm not looking.
Okay, when you're ready, look up.
You got to more than
Yes.
Yes!
Yes.
27 of 10.
Dates. You talking about?
It's coming to pro in this
Matt got it wrong. Matt got it wrong. Like Matt got it wrong.
Miss Willoughby?
Yes.
Try the bottom one.
We're about to do those together.
Can we try?
No, not yet.
Because you're gonna give it all.
You gotta you try. All right, I'll do the first one. I'll give you the second one as you try. Okay. Let's take a look at these. All right. So, we have a fraction.
Oh, yeah.
Okay. Who has an idea? Okay. What do you think, Andrew?
X to a negative.
A negative. So this 1/9 would be 3 to the negative second. Okay, so whenever we have a fraction, it's that negative exponent thing again, because negative exponent means reciprocal. So 3 to the negative second is 1/9. So now we have the same base, 3 and 3.
Are we supposed to be doing those?
Okay, so this gives us x equals negative 2 times x minus 3. So we get x equals negative 2x plus 6. So 3x equals 6, and x is 2. Okay, you try.
1 to 2 over 6. Is that 216?
That is 216. Yes, sir.
I thought it was 1 over 2 over 6. That's something right there. Well, you can do the reciprocal, and then you can end up getting the real answer even if it was 2 over 6.
Oh my gosh.
Yes. Yes.
Pain feels good. Let's do this. Both of them.
Oh, wait. That's at 6. What's the odd 216?
I can't figure out what I'm supposed to multiply it to.
What's your base? What's a common base for 36 and 1 over 216? 6. Yeah.
How many
So
times?
36 times 6 must be 2 more.
Oh, that's 6.
All right. Oh, we talked about your cubes that you had to know. You agreed on your summer work to memorize them.
But I lied.
I didn't sum
So that means it's negative.
I don't know my squares.
You got no.
Is it 22/7?
No. Then practice them in the car on the way to school.
I have physical therapy tonight.
Practice them on the way to physical therapy.
Okay.
There you go.
You can practice that. Shh. No, I can't. I'm busy doing stretches.
Oh, you beat me to it.
And my hip, my pinched nerve. I have a pinched nerve. In where? Like my back. Dude, my lower back, left of the spine.
Oh,
Huh.
I didn't add that up.
I'm not even kidding you. It's in my leg now.
Why is it my opposite? High five. It's like, ow.
Oh.
Back hurts.
I love how we're celebrating this. It's really
I know. I can't do squats and wait. Oh.
But you
I
can
don't
do
know
math.
how to do this.
You can do math.
I
Go
would
ahead.
do this, but I do it. Okay, Matt. Just stop making like a fantasy world.
Just stop trying to make fun of pinch nerve.
Plug it in.
This is in GTA 5. I'll back you up just 10 seconds. Okay, I can't play the next down, right?
Again.
I'm not wrong.
I know our house is
So I made a little bit. I put over 9. I forgot I said that.
forgot Shannon yesterday.
Like you left her?
Yeah, for the third year in a row.
No, it's not. It's -3.
Oh, it's like
All right, how did you do? Did you get negative 37 sevens? Excellent.
Wait, why are you?
I almost got that.
So that you don't just stare at the problem and try to figure it out.
She wants us to actually use our
It's
knowledge.
my brother. It's my brother.
I like that technique.
Okay.
I'm teaching.
Okay. So, what's wrong with this problem?
It's messed up.
It is messed up.
It must be right.
Okay, tell me what we've got to do before we can start to solve this.
Change the decimal into a.
Okay, you want to change the decimal to a fraction. All right. What else? What's our next idea?
Can we just do this again?
eliminate the fraction?
How?
You can times it by 4.
Do you set an equivalent base now?
All right. Have you noticed on every single one of these, we had 1 equal to 1, 1 equal to 1, 1 equal to 1. Was there plus or minus anything anywhere?
No.
So what do we need to do? Eliminate this. How? Yes, we just subtract it. And when we subtract it from 1, what is 1 minus 3/4?
1/4.
1/4. Now it's easy, isn't it?
Yep.
Yes?
I know what to do. Even I know what to do. That's sad.
Yeah?
I don't know.
Oh, I do. No, it really is. I literally
Matt,
Oh wait, we're supposed to do this?
tell me what to do.
Oh, you multiply the.
No,
one on the left
I'm
with
sorry.
the
The other Matt, because he hadn't paid attention like most of today. All right, talk me through it. I'm ready.
Yeah, let's go, man.
Come on, do the same base.
Okay, what is it?
To get us to 2, you would 2.
Seriously, boys?
Said that way too loud.
It's kind of loud.
That was.
Well, somebody else told him the same base of 2 just a second ago.
You got really lucky.
I'm sorry.
All right, so we write it with the same base of 2. So now we have equivalent bases, and once we have the same base, we set the exponents equal to each other and solve.
How'd you do that? Tell me.
You don't know how to set the exponents equal to each other.
Yes,
Will
Andrew?
that always be the case?
That it always equals 1/4?
No, like if it 2 like we're at -3, say if that's a different number, will it always equal
No.
2 to the right?
And you know what? Sometimes we can't do it. Or at least we can't do it this way. Because what if I gave you a problem like this? 2 to the 5x minus 1 is equal to 3. Can you write them with the same base? No. So there is another method. We're not doing it this year, but there is another method. And to solve this, we would use something called logarithm. And I can't wait to teach all that, but I have to wait until next year.
Is it
Where
easier?
will we have you?
Next semester.
Currently, I teach this course and the next course. That doesn't mean you will have me, but currently I teach both of them, and that doesn't mean I'll teach both of them next year.
Will we have you next
Teachers
semester?
too.
Yes.
Generally, schedules do not change, but like at the beginning of the year, remember how they collapsed my second period and opened up a new one, and sometimes that does happen at the beginning of a semester. So usually you have the same teachers, but sometimes things have to change. So, all right, here we go. Last one. How is this one different?
There's inequality.
There is an inequality instead of an equality. But the process is exactly the same. So all we would do is rewrite both of these with a base of
2.
2. So this becomes 2 to what? 2 to the second. And this becomes 2 to what?
The third.
2 to the third. And the only difference is that instead of an equality, we would have the inequality, less than or equal to. So we get 6x is less than or equal to 3x plus 3. So 3x is less than or equal to 3. So x is less than or equal to 1. Now, the only change would be here. If you multiply or divide by a negative number, then you must switch the inequality.
Hasn't that always been the rule?
That has always been the rule. I just don't want you to forget that rule. All right, your homework can be found on the back of the half sheet we did the other day.
I don't have to.
Okay, luckily for you, I accidentally printed extra.
Yeah.
I accidentally